Welcome to another coding tutorial, and in today's video I'm going to show you how to create this interactive sketch using the machine learning library ml5.js. This is the final part of the three-part series on Truchet Tiles. In the first video, we learned how to create a grid of hexagonal tiles, each containing a unique Truchet tile pattern. And then in the second video, we added some physics using the matter.js library. And in this final video, we're going to be adding some playful interaction using the body tracking model from ml5.js. I used a version of this sketch to create this interactive installation, and I'll share with you the behind-the-scenes video soon with everything I learned along the way. My goal is to provide you with a simple and approachable way to explore creative coding in physical space with just a P5 sketch, a webcam, and a body tracking model. First, we're going to go to this website, ml5js.org. All right, let's click Get Started. And the model we're going to be using today is the bodyPose model. And I'm actually going to go to the first example here and open it in p5.js web editor. The reason that I'm using the bodyPose model is because, one, I don't have it in my set of tutorials that I have already, but also because of the interactive installation, I wanted to be able to track the whole body. But as you can see here, because of this setup, it might be a little bit overkill because honestly, we're only going to be using 2 points, which are the points on the wrist. Why don't we just quickly go through the code here first? All right, so there are a few variables here. The video is the variable that captures the webcam video here. And as you can see in setup here, it creates the video and then it hides it. So if it actually does not hide it, you actually see the video at the very bottom here. But we hide it, but you can still see the video, and that is because the video is being drawn again at draw here on the canvas. Next, the bodyPose is the variable that contains the model, ml5.bodyPose model here. And then the poses is an array that keep tracks of all of these green points. And then connections actually is, it is a method inside the bodyPose model that keeps track of all the skeleton points, I believe. Actually, we're going to go quite simple right now. So what we're going to do is we're going to actually I'm not going to use any of these connection points. So I'm going to delete them first. But we're going to be focusing on the poses. But before we go there, I want to show you that we have another callback function here called getPoses that basically when it tracks the video that you see here, it outputs the results, which are the points that you see being drawn as the green points. Okay, so let's click run again. Now you should not see the red lines anymore. Okay, and inside draw here, we're drawing the webcam video, right? And then we're drawing all of the tracked landmark points. So what I want to do is that I want to first print out pose, which basically is the pose is one body pose or one body that is being tracked, which is my body right now. Click run. All right, let's see. There are a total of 17 key points. And each of these are objects that has X and Y coordinates. And confidence is the confidence level that particular body part is being tracked. And it also has a name, nose. What is this? Left eye, probably right eye. The one that we're going to be using is actually 9 and 10, which is the left wrist and the right wrist. Let's click run again, and I want you to notice something. When I raise my right arm, you can see that the video is not mirroring that, right? So what we want to do is that we want to actually flip the video as well as the model. So to do that, what we can do is we're going to write a variable called options, and we're going to set flipped to true. And we need to flip both the video and the model. So why don't we start with the model? Actually, yeah, let's start with the video. So just provide the second argument inside the create capture function here. And now the video is flipped, but you can see that the points are not flipped yet. So now just put in options inside the ml5.bodyPose function here. All right, and then now both the model and the video are flipped. The example is using the older version of the p5.js library. So I'm actually going to change it to the 2.0 version because that is the version that I've been using for the first two parts of the video series. And we also need to change some things here, specifically this preload function, because inside the 2.5 update, we're not using preload to load anything anymore. We're going to use the async and await format, and it's very simple to do. You just need to put the word async in front of the function setup here, and then I'm going to copy this and then put it inside setup as well. So we're not going to be using the preload function anymore, but we have async here, and then we need await in front of this line of code. And if I click run, it should provide the exact same thing. Perfect. Okay, so now it is tracking the whole 17 points, right? But all we need is actually 2 points, the two wrists. So we're not going to need the nested for loop anymore. What I'm going to do is I'm going to delete this setup for loop, and then we're going to write let left hand. It's hand wrist similar. I'm going to use left hand to be equals to pose.keyPoints, and I know that the number is 9. And then for right hand, it is going to be pose.keyPoints of 10. Then I can delete this. And then we're going to say that if left hand dot confidence is greater than 0.1, then we're going to draw this, and maybe how about we write a text that say left at the same location here for left hand, and let's do the same thing for right hand. Right. And you can change the confidence level here based on your setup. All right. Run. Right, left. Okay. If I move away, you can see that it is less jittery. So just be aware with that. So if you're only using this close-up camera, maybe the hand pose model might be better, but it gives you options. Next, what I'm going to do is that I'm going to show you how to scale the video. But as you can see here, because the canvas size and the video size are the same, you really don't need to be scaling anything, and your video is working perfectly fine here. But that might not be the case, and it was not the case for my interactive installation. So I would need to be scaling the video and make sure that the video is not distorted. All right, so let's say that we have a video of size 640 by 480, which is what we currently have here, but our canvas size is 400 by 400. To make the video fill the canvas without stretching, we calculate two scale ratios, and we can do that by dividing the canvas size by the video size. And then we're going to take the larger of the two scale ratios as our scale factor. And the reason is because that's the amount of scaling needed to make sure that the video covers the entire canvas. The side that needs the most scaling will fit exactly, and the other side will overflow slightly. And once we apply the scale factor, one dimension will match the canvas exactly, but the other side will be slightly larger. And from there, we need to calculate offsets by taking the difference between the scale size and the canvas size and dividing by 2, which lets us crop the overflow evenly on both sides. So to do that in the code, what we're going to do is first, let me change the size of the canvas to 400 by 400. Now you can see that it is being squished, right? Because our video size is 640 by 480, but we're drawing it at width and height, which is the size of the canvas. So now what we want to do is, let's comment this out. First, why don't we declare 4 variables for the canvas size and the video size. So the video width will be equals to video.width, and video height will be equals to video.height. And then let's do canvas width, which is just width, and canvas height, which is just height. This just makes it easier for me to distinguish between the video and the canvas width and height. And then now we're going to find the ratios of the width and the height, right? So let's do let scale to be equals to, and we want to get the maximum of the two. So let's just do max between canvas width divided by video width and canvas height divided by video height. And scale will already pick the maximum one. And then after that, we're going to multiply it using that scale ratio to the video width and video height. So the new scale width will be equals to video width times scale, and scale height will be video height times scale. And then after that, we're going to be calculating the offsets, right, for the overflowing part. So to do that, we just do dx equals to, we find the difference between the two, and we want the larger one to come after because we want it to be negative so that we can offset it off the screen. So because dx and dy will be the point at which the top left corner point where we start drawing, right? So it's always that the scale height will be larger, so we need to do canvas first, right? Minus scale width divided by 2, dy equals to canvas height divided by 2. And then we're going to draw out the video at the new offset coordinate dx and dy, and then the width and the height will be scale width and scale height. We can delete this. Does that work? I think it did work. And let's say that we change it to like 400 by 200. So it's just basically cropping the video such that nothing is being distorted. Okay, so now that we have this, why don't we put it back to our Truchet Tiles code, and then we're gonna start making the interaction part. So this is the code from the second part of the video series. So we're going to change a few things, and then we're gonna add what we just did from the bodyPose sketch into it. So first, what I'm gonna do is I'm going to actually change the canvas size to 500 by 500. And then I'm going to throw in this line of code, pixel density of 1. And this basically ensures that the canvas is not being scaled differently for high screen resolutions, and so that the body tracking and the canvas coordinates are perfectly aligned. And now we're going to also actually delete the rotation part here. And yeah, let's click run. Okay, and I also want to change the size of the hex radius here to be a bit larger at 120. All right, that's it. Okay, so now let's put the other set of code inside here.
A few moments later.
I'm going to click run. Oops. Oh, don't forget to also inside index.html here to add the ml5 library. So all you need to do is copy and paste this inside their example, and that should work. Okay. Oh, the scaling doesn't work. I had not changed any of the scaling part. So we did the scaling of the webcam, right? But as you can see just now, what happens is the tracking points are not being scaled. So all we need to do is we just need to make sure that those points are scaled as well. So we cannot just use the left hand and the right hand points. Based on what is being provided from the model, we need to scale it. So let's do LH left hand x to be equals to left hand dot x times what? We're going to scale it, and then we're going to offset it. Same thing for y. Left hand dot y times scale plus dy. And I'm going to copy and paste this for the right hand. And this should scale them correctly. Oh, silly me. I'm not drawing it. So x, y. Basically, I'm drawing the O points. And same thing for here. RHX and then RHY. Nothing to worry about. Okay, let's see. Okay, you see, now it's tracking my left and right hands. Perfect. What we want to do now is we want to create some interactions. So what I want to do is that I want to use my hand position to be able to rotate the hexagon. To do that, right now, as you can see, we're basically tracking them separately, but I want to make sure that if my right and my left hand are both inside a hexagon, then it activates the hexagon, and then we're going to be able to rotate it. So let's do that. So now we have two separate if statements here. I'm actually going to combine them. So I'm going to put the right hand inside this if statement and create an additional condition here. So if left hand.confidence is greater than 0.1 and so is right hand, then we calculate all these scaled points, and then we're going to draw all of these. Okay, and then we can delete this additional if statement. And now, yeah, let's just click run to make sure that it still works. Okay, but now, as you can see, what I want is that if it is inside a hexagon here, I want it to activate this particular hexagon. So what we want to do is that we want to find the distance between the right hand and the hexagon middle point. What should be the dist L for left side is going to be, we can use the function called dist to find the distance between 2 points, and those 2 points for the left side will be LHX, LHY, and then we need the position of the hexagon, which, how about we set hex to be equals to, actually we need to go through all of the hexagons, right? So we need to write a nested for loop that goes through I equals to 0, I less than columns, I plus plus, for j equals 0, j less than rows, and then j plus plus. All right, so let's put this inside here. Okay, and also how about I set another variable called hex, and we're going to set hex to be equals to hexagons of I and j. So hexagons of I and j is the array of hexagon objects, right? And then inside here we can just do hex.pose.x, hex.pose.y. Okay, and that is for the left side, and then for the right side we do the same thing, but we use the right side points. Okay, and then now what we're going to do is we're going to say if distance left is less than hex L and dist R is less than hex R. Sorry, it's hex R for both, and this R is for radius. So if it's inside the radius of this hexagon, then we want to activate the hexagon, which we have not written it in the hexagon class yet. We need to do that next. So we're going to set hex.isActivated be equals to true. All right, let's save. And then we're going to go to hex.js here, and what we're going to do is actually we're going to be deleting some code here. So we're not going to have it rotate by itself anymore, so we don't need these, and we don't need a lot of these angles. All we need for the angles is the current angle for now. And then we're going to set this dot is activated to be equals to false initially. We're going to actually delete the start rotation method and also this whole thing that activates the rotation. If you want to see the code, you can go to the previous tutorial setup code, but for now, just to keep things clean, I'm going to delete them first. And what we want to do is we already set this dot is activated as false, and so we need to do something when it turns true, right? So what I want to do is I want to actually color the hexagon here, and I'm actually going to do, if this dot is activated is true, then how about we fill it with this dot C, which is the color we need to set that to, and then else no fill, and we keep the stroke as white. Okay, and what is this dot C? So we don't have this dot C yet, so let's do this dot C to be a random color inside the color palette, which is, the name is palette. Okay, save and run. Okay, so not activated, activated, not activated, but why is it still there? Activated, activated. Okay, so we want to also reset the hexagon here, the activation, right? And you might think that we can just put in here an else statement, right? So if it's not there, then just set the activation to false. But because we're going to be dealing with multiple people using this, what I'm going to do is actually, in every time we go through the draw loop, I want to set all of the hexagons as false, activation as false first. We're going to write another nested for loop that goes through all of the hexagons. And then I'm going to set hexagons of I and j dot, what is it, is activated, and set it to false. And this should do the trick. Activated, not activated, activated. And you know the jittery part that you see, it's because of how close I am right now. But at the same time, it also can be changed in the confidence level as well. So just play around with those values. Okay, so next, what we want to do is that we want to be able to actually use, not only just activate the color, right? We want to be able to rotate it and have the hexagon rotated with us. So what we're going to do is first, we're going to find the angle at which the two hands make. So to do that, we are going to come down here and we're going to calculate two values. The first one is the difference in the x direction, and then the second one is the difference in the y direction. So actually, before we do that, I want to show you this function here, a_tan2. It calculates the angle formed by a point, the origin, and the positive x-axis. So as you can see from this example here, the point that you see is the point from my mouse x and y, right? And it is the angle that is being made between the origin, which is at the top left corner of the canvas, and the mouse position from the x-axis, and the value ranges between -pi to pi. So we're going to be doing a very similar thing, but instead of having it be from the mouse location to the origin point, it is actually going to be from the two position of my hands, right? And to do that, we just need to find the difference in the x direction and the y direction and use the a_tan function and provide the y value and the x value. And then we're going to get that angle. So let dx to be equals to RHX minus LHX. So I want the point to be pointing from the direction to be from the left side pointing to the right side. And that's why I use the right side as the first number and get it subtracted by the left side. Same for y, so RHY minus LHY. And then we're going to be using, find the hand angle by using a_tan2 and provide dy and dx. And then we're actually going to set hex dot target angle to be equals to hand angle. And we don't have target angle yet, but this is basically is the angle that we want to set the current angle of the hexagon to. So now that we have this, then why don't we actually draw out the lines? So we can draw, let's do stroke to be the color, let's do red. And we do line that goes from LHX, LHY, and RHX, and then RHY. Okay, so you see the line here. It doesn't do anything yet, and then once it's inside here, you can't see it anymore. But you can see that once it goes off, then the hexagon is not activated. So now the angle is being calculated already, so we're going to use that to actually turn the hexagon. So let's go to hex.js here, and inside here we want to add another variable here, target angle. And actually inside the draw hexagon where we did this conditional statement, so instead, what if we just do stroke for now so we can actually see it? So we change the color of the stroke to the color of the palette if it's activated. If not, we set it to white, and then we just do no fill. And how about we do stroke weight to be a bit thick at 3? And then what we want is inside update, why don't we just set this dot current angle, which is the angle of the hexagon, to be equals to this dot target angle. And also we need to make sure that it is when the hexagon is activated, right? So is activated is true, then we do this. Equals. Nothing happens. All right. But you can see, because it is, we basically just set the angle of the hexagon to be the angle of that is between the left and the right side of the hands, right? It's a little bit jittery, and we can make a smoother rotation by making sure that the angle changes with a particular step instead of just moved to that point right away. So to do that, I'm actually going to delete this, and we're going to, how about we set let angle step, and we set it to 0.2, and you can change this value too based on how smooth you want your hexagon to move. And then I'm going to find the difference between these two angles, right? So we know how much to move. So this, let's call it diff to be equals to this dot target angle minus this dot current angle. And then we're going to increment this dot current angle by diff instead, multiplied by this angle step. All right. I think it's a little bit smoother. Okay, but once it is being not activated, you can see that it just stays where it is, right? But what I want is that I want it to snap back to the original position. So we're going to put in an else statement here. So else what? Else, let's do snapped interval, which is pi over 3, which is how much each rotates by, so that it actually snaps back to its hexagon position. And then we're going to find the nearest snapped angle. To do that, first, what we need to do is that we need to know what is the closest ratio. So what we're doing here is essentially finding the ratio, the closest ratio to whatever the interval, the 60 degree of pi over 3 is, and multiply by that, so that we have this nearest snapped angle, and then we're going to find the difference from the current angle, and then we're going to rotate it there. All right, so we're going to do round, and we're going to do, no, not snapped interval, it's going to be this dot current angle divided by snapped interval, right? To get the closest one as a whole number and multiply by snapped interval. And then we're going to do the same thing where we find a difference between, this time it's going to be this dot current angle minus, no, it's going to be nearest snapped angle minus this dot current angle. And then we're going to increment it by angle step. This one is also angle step. And then, yay, okay, you see that? Nice. Okay, let's try a different hexagon. Okay. All right, so now I'm actually going to add additional calculation to make sure that the angle difference that we use to increment is actually robust or efficient, I guess. For example, because right now the angle that is returned is ranging between negative pi and pi, or negative 180 to 180 degrees, right? But let's say that the difference between the angles, like the angle that we use to subtract, as you can see here, right? This dot target angle and this dot current angle, what if it's between negative 179 and 179? So that subtraction can go to 358 degrees, right? Negative 358 degrees. But actually, the shortest path could just be 2 degrees. So we're going to use this trick using the a-tan of sine and cosine function to find the shortest path. So what we need to do is, I'm not going to go through the math behind it, but this calculation will give you the shortest path. So I'm going to actually use a new variable. Let's call it angle diff equals to a-tan of 2. And then we're going to put in sine of diff and then cosine of diff. And by using this, it gives us the shortest solution. And we're going to do the exact same thing for this as well. And you might not see the difference in the execution here because it has to be like a wraparound case, but just so you know, having that will give you the option such that the hexagon is not moving in a less efficient way. One last thing that I want to do in this interaction part is that right now our hands have to be exactly inside the hexagon for it to activate. What if we give it a little bit of a buffer? So inside sketch here, I'm going to create a few more variables. So let's set it underneath settings. So let's do hand buffer. How about we do maybe 40? And instead of having it activated exactly at, if it's less than hex.r here, I'm going to add some buffer, hand buffer. Okay, as you can see here, it activates now, even if it's not exactly inside the hexagon. And you can change the buffer as big or small as you want. Perfect. Lastly, I'm going to be working with the camera. So right now, the camera that we have is the webcam camera, right? But when I was doing my interactive installation, I have an external webcam. And you might have a set of different kind of webcams or options that you use as a camera to track yourself. So we also want a way for us to be able to choose which camera we want to use for tracking. and I'm actually going to write maybe here before video. Let's create a variable called devices, and I'm actually going to copy and paste this. Await navigator.media_devices.enumerate devices, and let's just print it out what exactly this is. Print devices. Okay, so it has 9. Why are there so many? And some of them are not video input, some of them are audio input from my MacBook Air microphone. Some are, this is still audio input. What we want is actually a video input. Wow, they're all here, video input, right? My FaceTime HD camera. So we want to put all of these inside an array. So how about I create an array called cameras, and then I'm going to loop through all of the devices, devices.length I++, and say that if devices of I dot kind, right, kind here is equals to video input, then let's add it to the cameras array. Add what? I want to add devices of I. And I'm now going to go through the cameras array, and then I'm actually going to print out, and this is for you to see how many cameras are there and which index do I want to use as a camera to put inside my create capture function here. So let's print out the index, and then let's make a nice colon here, plus cameras of I, and then dot, and then how about label? I just want to see what's the name of it. Okay, so I have two. One is the FaceTime HD camera, and the other one is OBS virtual camera, and you might have more in your case, right? So what I'm going to do next, inside underneath setting here, let's put camera index, and we're going to be using 0, right? Because this is the one that I want to use, and this is where you can change it based on the camera that you want to use. And instead of just providing video here, I'm going to copy and paste this set of code that I already wrote out. Basically, this is a common way for you to specify video and audio settings. For our case here, we're only using video, right? So as you can see here, audio is set to false, and the syntax is a little bit different, but let me help you walk through here. So the device ID, we want to set it based on the cameras of the camera index that we want, right? So here it's basically saying that, hey, please use this exact camera index ID of this particular device. If not, then tell me that it's undefined. But for the width and the height, ideally set it to 640 and 480. But this is not the exact one. So if you can't find it, it's okay. And for the frame rate, same thing, set ideal to 30 and also max to 30. And instead of video here, we're going to put in constraints. This is something new to me too. So yeah, I was doing a bit of changing of the setup, and so making sure that my camera settings is also the one that I need, and make sure that the width and the height setup is configured correctly so that it captures the images nicely. One more thing to be aware is that with these two numbers here, the ratio needs to be the same as the ratio of your video. If not your canvas, your video. If not, the image here will also be distorted. So yeah, that's it for this part. Let's click run again to make sure it still works. Okay, All right, lastly, I want to spew out all of these new boxes, right? Inside here. So maybe after all of these hand tracking stuff, here we're going to say if random is less than 0.8, then we're going to push new boxes. Ooh. And we want to do it randomly based on width and height. And then I also want to make sure that it doesn't clog up the canvas. So I'm going to, inside settings here, set the maximum boxes that I want on the screen. How about we do 100? And then we're going to use a while loop right after this. Okay, right after we create all of these, we're going to say while boxes.length is greater than max boxes, I want it to keep removing it from the array. So we're going to be using the same function method here, boxes of I dot, no, it's not going to be of I actually. We're going to be removing the first one in the array. This is the function that removes it from the world, right? The matter.js world. So we also need to remove it from the array as well. So we're going to do boxes.shift. Basically, shift takes away the very first object inside the box array, inside the array. So with this, it should work. And I actually want to go back to Hex again, where we did, let's find stroke of this.c. How about we do stroke of white here, and then let's do fill here, and no fill. Okay. Let me stand up and then rotate. All right, so this is the very last part of the video series on Truchet tiles, and it is a lot of fun because I got to actually use this sketch or a very similar version of this in my very first interactive installation, which I'm going to be posting the behind the scenes where I talk through everything that I've learned. So I hope that you really enjoy this whole series. It has been a lot of fun for me to make it, and yeah, so give it a try and let me know if you like this kind of series and what else you want to see. Bye!